Dear student, okay, here you can see three different images. Okay, one it is these two are cooking, and this is somewhere it is heating. Okay, here these are the common things. Okay. The thing is that we are going to change the property of this material by using a method called heating. Okay, for example, see we have a potato. Okay, potato is hot before boiling. Boiling is type of heat treatment. Okay, before boiling, it is the property of potato is hot, but after heat treatment, it is becoming soft. Okay, when we take meat. Okay, for a meat it is soft. Okay, but no, it's hot. We cannot tear it with the hands. Okay, but when it is heat treated, it becomes soft. So the changing of property of a material can be easily done by a heat treatment. Okay, heat treatment is nothing but you are going to have a controlled heating and cooling of a process. So there are three steps in a heating. First is controlled heating, then soaking. Soaking means holding for a certain time, then cooling. Okay, by doing this type of process, we are going to alter the properties like strength, ductility, hardness, toughness, machinability. For example, see, you consider this is a steel plate. Okay, I have to use this particular material for a purpose where for a machining purpose. Okay, but if it is so hard, we cannot do machining. Okay, for that purpose I have to a heat treatment to soften this material or to change the property of the material so that we can machine it easily. So for this type of altering the properties, we are going to use the heat treatment. Okay, what is the purpose of heat treatment?
So purpose of heat treatments are we discussed to soften the material. So for example, if the metal is hard, to soft we can use the heat treatment. So this is one purpose. Another one is to relieve internal stress. So as we already said, inside materials there are many stress. To relieve that, we will use heat treatment. Okay, now also refine grain size. To refine grain, we need to grain some materials. So for that we can use some heat treatment.
From collectively we can say to improve the mechanical property. From collectively we can say we can have to improve the property of a mechanical property or a physical property of a material. Okay, where we are going to use it?
So we will use this heat treatment in foundry, aircraft, industry, and making of utensils, and so on. In the defense sector, we can choose on the camouflage industry of tanks and other areas.
Okay, good. Okay. What are the types of heat treatment?
So there are 4 types, namely like annealing, normalizing, and hardening and case hardening.
What do you say about annealing?
So annealing is nothing but it is one of the type of heat treatment. But the difference is, if we heat one material, we will cool the material inside the furnace. But the main point is, the cooling rate will be low and the cooling time will be high. Okay.
Here the thing is that cooling rate, as Sachin says, cooling rate means cooling rate per second means for a second 1 degree is getting lower in a normal state. But when you keep the specimen in a furnace, workpiece in a furnace has to get cooled, then only the workpiece is going to get cooled. Okay, at the time the percentage is decreasing, the percentage is the temperature will be, the reducing of temperature will be at a very slow rate, so the rate is going to less. Okay, what are the next one? Next type is
Normalizing.
okay. What is meant by normalizing?
So normalizing is the process of reducing heat in the metals. Comparing to annealing, normalizing gets more cool than annealing. Annealing has coarse grains, but normalizing has fine grains.
In other way, you can say here the normalizing part is that you are going to heat the material, soak the material, and then cool the material. But the cooling rate is slightly higher than annealing. As you said, it's because the cooling is done in the normal application. Okay, normal. Okay.
So in hardening, we after heating the steel in the furnace, we immediately put the steel in the water as a quenching method. So while we do the hardening takes place more harder, the metal gets more harder, and it gets fine pure grains.
So this fine grain means, fine grain is like there are fine grains means the atoms are arranged in a very closed manner, so that this fine grains, the strength of the material is for fine grain material, the strength is higher, which because the crack cannot travel through the grains. Okay, so the fine grain material will have the high strength. When you say annealing, it has a coarse grain material. So coarse grain material means that the crack can go through the what are the material, what are the grains. Okay. With the next one.
Hard, tough, tempering. Now coming to the workpiece, we not only needed the hardness, we also need the toughness of a material. So we have to increase the toughness of a material. So we uses the hardness, it will be decreased and slightly, but the toughness will be increased. So like that, for an example, you can say the normal glasses we use is a hardened material, and the tempered glass we use is known as the tempered materials. So toughness is also needed for a material.
Added to that, you can say tempering and hardening and tempering are the like pins. Okay, we cannot completely harden the material. Apart from hardening, we have to do the tempering as which, because as our friends say, the hardened material cannot be used on all the applications. After hardening, you have to do the tempering in order to have the toughness. The toughness means for the resistance to a sudden impact. Okay, if you drop the phone unknowingly, the tempered glass is going to break. The display is not going to break. Means that the tempered glass will take all the impact so that it will not harm the display. As like that, the tempering is the process where you are going to increase the toughness of the material, but decreasing the hardness, but not at the higher level, but at the slower level. Okay, thank you.